Hi guys, in this video we're going to cover solving double right triangles. We're going to do 4 examples. Let's get to it. So we're going to take a look at some pirate ships. Arr! An observation on a cliff 1,200 feet above sea level sights 2 ships. One is due east with an angle of depression of 48 degrees. The other is due west with an angle of depression of 33 degrees. How far apart are the 2 ships? So I should start by saying, if you need a review on angle of depression and elevation, you can go check out my other video or the millions of videos on this topic that probably exist on the YouTube. So let's solve this problem. So the cliff is 1,200 feet tall. So that would be straight up. And now what I'm going to do is I'm going to place some other labels. So I'm going to label this X and this Y. I'm going to label each triangle individually, as I've done in my previous trigonometry videos. So I'm going to label this straight out, and this is O, or the opposite leg. Across from the right angle is H, or the hypotenuse, and this is adjacent. Now I'm going to label the other side, and when I draw angle straight out, I have O. Across from the right angle is H, and this is A. And now I look at what I have, which is the opposite leg, and I am looking for the adjacent leg on this half, and I am doing the same thing for the other half, which leads me to the tangent ratio, which most of these double triangle trig problems will be. In fact, this video series is very tangent heavy. So now let's get working on solving these. In my previous video, I've pushed heavily the process of cross multiplication, and I stand by that. If you are struggling with cross multiplication, I should say, in trigonometric ratios, this is a great time to get a lot of practice, because for each problem you technically have to do it twice. So that is 1,200, then x times tangent 33 is x times tangent 33, and now I'm going to divide by tangent 33 and divide, ooh, that's terrible, divide by tangent 33, and let's see what the calculator tells me x equals. And the calculator tells me that this side of the triangle is 1,847 feet, 0.84. So this side is 1847.84. Alright, now I'm going to solve the other side. I would highly recommend from here that if you are comfortable in cross multiplication, you can really just skip ahead. But I'm going to go through all the steps just for fun. So 1 times 1,200 is 1,200 equals x times tangent 48. Now I'm going to divide out that tangent 48 on both sides. I butchered that. There we go. Tangent 48. And now I'm going to see what that equals according to my calculator. And the answer there is 1,080.48 feet. So this side is 1,080.48. Now I have to add these together. And the reason why I'm adding them together is because what I want to do is get this entire distance here. So with the limitations of trigonometry, which only allows me to work right now with right triangles, the way the problem was solved was to add an altitude and create two right triangles. Then add that space together. And when I add them together, I get 28.32 feet. So the pirate ships are 2,928.32 feet apart. The other thing I want to mention before I start shooting forward is that notice the symmetry in the problem. So really, you did not have to cross multiply twice, because it's going to turn out to be the same thing each time. In fact, if you have a good calculator like the TI calculator that I have, or a good Casio calculator, you can just press the up button and really just change the angle, or theta. So you can change the reference angle here in the calculator and you'll get those answers. Most of these triangles are symmetrical. The only time I was able to create a word problem that was not symmetrical was in space, where two objects could move three-dimensionally from infinite amount of directions, which none of these problems are going to pertain to that, so therefore we're going to pretty much be working with symmetrical triangles. Alright, let's take a look at the next example. So once again, we're working with pirate ships. Kind of looks like a fun job. An observer on a cliff 1,200 feet above sea level sights two ships. Both are due east. The angle of depression in are 48 degrees and 30 degrees. How far apart are the two ships? So, this problem is a little bit different, but not by much. In fact, if you notice, it's using the same exact angles as it did before and distance. The issue that students often have with this problem is they fail to recognize, or struggle to recognize would be a better word, that this is really two triangles on top of each other. So in other words, if this cliff is 1,200 feet here, this triangle, when I label it, that is the opposite leg there, and that's adjacent. Then this triangle here is also opposite. So it's opposite for both triangles, just like before. But the big difference is that this here, this space here is not A, because this triangle here is not a right triangle. So you need to create one by finding that whole distance. Pre-calculus actually has a solution for this that's not covered in this geometry class, and that is trig identities. What we have to do here is we have to create an x and a y, just like before, and perform the trigonometric ratios and the algorithm within twice. I should say this, if you're familiar with trig identities, you would probably recognize that it's not really that much less work. What ends up happening is to solve for that distance, you just don't need the second triangle. Now, let's get started. So the setup to these two triangles is the same as the first example. So I saved you the time in all of the cross multiplication and the different answers. But if you need practice cross multiplying, this is a great opportunity. It is very repetitive. It is monotonous, but you will get good at cross multiplication through this process. Let's take a look at what we have. This length here is 1080.48, and this length here is 1847.84. To find this length here, what I need to do is I need to subtract these numbers. So I need to subtract 1847 from 1080 to get 767.36. Okay, the next two examples I'm going to fly through, but they are the same as these. What changes is the orientation at which the triangle is set. These types of problems, just like the pirate ship problems, are very common in standardized tests. So let's take a look. Joe is standing on top of a building next to the Burnett Building in Chicago. It is 880 feet between buildings. The angle of elevation to the top of the building is 8 degrees, and the angle of depression to the bottom of the building is 20 degrees. How tall is the building? So now, we want to know how tall this building is. I have the two triangles again, so I'm going to label this X and Y. I am going to draw an arrow straight out from my reference angle, and that's going to be my opposite legs of the triangle. The hypotenuse will be out here across from the right angle, and this will be the adjacent side. So while I'm using tangent again, what's going to happen is it is going to be very tricky to make sure that you don't flip the ratio. That is a constant or consistent issue that students have with these problems where they get them wrong. So now I'm going to save you the joy of watching me cross multiply twice. Not to suggest by any means you should be skipping these steps if you are uncomfortable with this process. You should absolutely follow through. I guarantee you, and this is usually what happens with my students, if you cross multiply these problems over and over again, you start to see a pattern and you become a whole lot more fluid in right triangle trig operations. So now I got these two answers, and just like before, I'm going to add them together. So 123.68 plus 320.29 is 443.97. So this here length is 123.68, and then y, the length of that, is 320.29. One of the things I'd like to take a second and point out, 8 degrees is a little bit less than half of 20. And notice how the lengths are a little bit less than half of each other. Those types of things really help us navigate trig, right triangle trig, a little bit more fluidly and fluently, so we could kind of start predicting what we have going on. Alright, let's take a look at the last example. Just for the record, as I put these videos out into the universe, I do not make up these problems. Most of them come from years of finding them in standardized test booklets and state test guides. So now let's take a look at this problem. At a point 200 feet from the base of the building, the angle of elevation to the bottom of a smokestack is 35 degrees. The angle of elevation to the top is 52 degrees. Find the height of the smokestack. So I already mentioned, if you need help handling angle of elevation and depression, you could check out the main videos on the YouTube or my video that I made previously. But in this scenario, we are looking for this distance here. Now, what's going to happen is I'm going to label my angle. So this angle here is 35 degrees. Now, this angle is not 52 degrees. The entire angle here is 53 degrees. Hopefully that helps. you guys kind of visualize how these triangles work a little bit. And this is the opposite leg. And then here at the adjacent leg, I have 200, and that's H for both of those triangles. While these problems all work out the same, one of the things that really helps students is the repetitiveness in them. So, label your triangles, go through these steps, even though the proportions may have become obvious to you. This way, when you get a problem that's a little bit more difficult for you or disorienting, you can just mechanically go through those steps, the algorithm, and hopefully it'll help you find the answer in more difficult problems. So now let's set these up. Okay, I'm going to cross multiply these individually as I have before. So 1 times x is x, and then 200 times tangent 35, as far as we could tell, is 200 times tangent 35. We can't put those together yet. So 1 times y is y, and then we have the same thing on this side. Okay, so I want to teach you guys a little trick here, and one of them is, if you have a really solid calculator, you can just subtract the functions or add the functions. So in other words, what I can do is I can place into the calculator, specifically in my case this TI-36X Pro. My calculator does not require for me to place the multiplication symbol in there, and I can just subtract them this way. For those of you who are a little bit more advanced, I would highly recommend this practice. And the reason for it is because as we move to more advanced maths, we kind of move away from numerical values. We often try to solve problems in the general sense, and we don't focus on specifics. In this case, the answer I got is 125.37. Now, if you need to break this up into individual steps, because you do not have one of these calculators, at 140, at 35 degrees, I got 140.04 feet. And then, let's see, at 53 degrees, I got 265 feet. So it is kind of proportional here. It's actually very proportional about how much we are gaining based on the angle. So again, I reiterate, one of the nice things about right triangle trigonometry is it is very physical, and you could definitely track and make sure you're getting the right answers just by physically looking at the problem. Alright guys, I hope you have found this video helpful.